So let's look at this multi-step synthesis reaction, which we're going to break down into the individual steps. But first, just take a second to think about the individual steps that have to happen at some point in the reaction. We start with an alkene in this cis conformation with the hydrogens projecting off the same side, and finish with this trans configuration for the alkene with the hydrogens on opposite sides of the carbon-to-carbon double bond. So we know a reaction in the alkyne chemistry to turn an alkyne into this trans configuration of an alkene. It was the anti-addition method that used lithium and ammonia to make that happen at minus 33 degrees Celsius. So it looks like at some stage this reaction must happen. We also know about reactions with potassium hydroxide in ethanol, which strip away hydrogen and a halogen from either side of a carbon-to-carbon bond to produce a pi bond. So if we take two equivalents of potassium hydroxide, we can do this twice over, make two pi bonds, or make a carbon-to-carbon triple bond. And of course, if we're going to strip away halogens to make a pi bond, we need to have halogens in the first place. So we could use something like bromine in dichloromethane as solvent, or even chlorine in dichloromethane as solvent. So these look to be the three main elements of the reaction. It just depends on the order that we do them in. So if we start at the end of the reaction with that final trans alkene, of course the immediate reaction to get to that trans alkene would have been the reaction with lithium in ammonia. So that's probably the last thing we did. And of course, to produce that trans alkene, we must have started this step with the alkyne. Now, previous to that, to produce that alkyne, which we didn't have originally, to produce it, we know of the reaction with potassium hydroxide and ethanol, stripping away hydrogen and a halogen from a carbon atom twice over to form a carbon-to-carbon triple bond. So it must have been the dibromo alkane that was in the previous step, turning that carbon-to-carbon bond into a triple bond. Of course, we didn't start with the halogens attached, so that alkene must have originally been reacted with some bromine and dichloromethane, and we get back to that original starting material, the cis conformation of the alkene.